Okay, so we want to start our study of probability. So let's think about when probability might arise in the real world. So let's think about managers and how they might base their decisions on the analysis of what we would call uncertainties. So often managers face uncertainties, such as this one, the first one. What are the chances that the sales will decrease if we increase the prices? So the chances, that's going to mean probability. What is the likelihood that a new assembly method will increase productivity? So here again, likelihood, basically probability. And this is a little bit different than probability, but basically the same thing. What are the odds that a new investment will be profitable? So these situations certainly occur everywhere and all the time. We're always faced with uncertainty. And probability sort of enables us to uh, deal with uncertainty sometimes by treating it mathematically. So we might talk about what's the probability that it's going to rain tomorrow, or what's the probability that I roll a 6, that I get a 6 when I roll a die, or what's the probability that the stock price will move up, or what's the probability that sales will increase if we take some kind of measures in our company. So what do we mean? What do we mean by probability? So in mathematics, we're going to say probability is a number. It's going to result in a number. For example, when we say what's the probability that it's going to rain tomorrow, we might say 50%, or we might say 20%, or something. So it's some kind of number. So the number should always be between 0 and 1. We never say the probability that something will happen is 150%, right? So it's always between 0 and 1. So probability is a numerical measure. So it's kind of, when we say the probability that it will rain, we're kind of measuring the probability of that event. In that case, the event that it will rain, or the event that sales will increase. What's the probability that sales will increase? So we're trying to talk about the event that sales will increase and assign a number to it, like the probability that sales will increase. We might say the probability that sales will increase is 80%. Or we might say the probability that it will rain. So the event that it will rain, we want to assign a number to that event. We might say 20%. So they say probability is a numerical measure with a number assigned to an event. And probabilities are always assigned on a scale from 0 to 1. So they are a numerical measure assigned to some event, like the event we said can be that it will rain, or the event could be that sales will increase, or the event might be that we get an even number when we roll a die. So you know what we mean by a die. Right? We have a die, and we might get an even number when we roll it. So that's an event, right? Whatever. Okay, so that's another event that we would get an even number, or like we said, the event that sales will increase, or the event that it will rain. So those are we talk about events, and we just mentioned 3 of them, and then we assign a number to the event. That number is the probability. So the probability that it will rain is a number 20%. So we'll write that as 0.2. The probability that we get an even number, maybe we'll say it's whatever, it doesn't matter what, maybe we don't know what it is, but let's pretend that it was 0.5. So that's a number that we assign to that event, and that we call that the probability, or the probability that sales will increase. Let's say we give that a number, let's say 80%. Okay, so we have events, and then we assign probabilities to them. And the scale is always between 0 and 1. And a probability near 0 indicates that the event is unlikely to occur. And a probability near 1 means that it's almost certain to occur. So it can be between 0 and 1. And of course, if it's close to 1, we think of it as almost certain. And if it's near 0, we think it's very unlikely to occur. Okay, now we want to talk about a word, and we're going to use this word experiment, and we're not actually going to. It's going to be used in a slightly different way than we would normally use it in physical sciences, like in chemistry, we do an experiment, or in biology maybe, or in physics we do an experiment. But when we talk about statistics experiment, we're slightly different meaning. In statistics, the notion of an experiment differs somewhat from that of an experiment in the physical sciences. In statistics, in statistical experiments, probability determines outcomes. Even though the experiment is repeated exactly in the same way, an entirely different outcome may occur. So we just talked about 3 events. We just talked about the fact that it might rain, the fact that we might get an even number when we roll a die, and the fact that sales might go up. So whenever we talk about probability and events, and these are all called events, there must be some so-called underlying experiment. So you may not think of that there's an experiment, but we want to say that there's an experiment. So in this case, this is the easiest example to say there's an experiment. The experiment is to roll a die, to take one of these dice and roll it on the floor, and then see what will happen. So we call that the experiment. So in this case, it's easy to understand that that could be called an experiment. You just throw the dice on the floor and then see what face occurs. So we talk about an experiment, and then we talk about the set of outcomes that are possible for that experiment. So the set of possible outcomes for the experiment of rolling a die. So what are they? When you roll a die, what could you get? We might get an even number, but we might not get an even number. But let's break it down into not just even and odd numbers, but we can break it down in a different way. And of course, what I'm talking about is we could say you could get a 1, could get a 2, you could get a 3, a 4, a 5, and a 6. A die only has 6, what are called 6 faces. So those are the only elements that could occur. And we write it as a set, so we put commas here. And so this is the set of possible outcomes for what we call the experiment of rolling the die. So you might say, why do we have to call it an experiment? But what we mean by experiment here is that it results in something we don't know what's going to happen. So when we roll a die, we don't know what's going to happen. It could be any one of these, so we don't know which one. So we call that an experiment. Just like sort of like when you talk about when you pour 2 chemicals together in a chemistry experiment, you might think, oh, you don't know what's going to happen, right? So that's an experiment, because we could say because you don't know what's going to happen. And so we could call rolling a die an experiment because we don't know what's going to happen either. It could be any one of these. And now this is a kind of a stretch if we have to say for this event, the event that it's going to rain tomorrow, what's the experiment is kind of a stretch. Like what could this experiment possibly be? Well, we just say the experiment is to wake up tomorrow and check the weather. We don't know what's going to happen until we look out the window. Then we know. And then here, the experiment would be to perform, to do some advertising and then check next month to see whether sales go up or down. So that's what we mean by an experiment. So they say in statistical experiments, probability determines the outcome. So in other words, we don't know what's going to happen. Even though the same experiment is repeated exactly the same way, so we roll a die, and we can roll it twice, and we do it sort of exactly the same way, well, that's kind of questionable whether it's really exactly the same way, but we're going to say we're performing it exactly in the same way. An entirely different outcome may occur. So that's what we mean by experiment here. And for this reason, statistical experiments are sometimes called random experiments, because we expect that we're saying that we don't know what's going to happen. So let's look at some examples of experiments. So I think we had one of them already here. So we said we can roll a die, and then we can say, well, what are the possible outcomes? And for that experiment, these are the possible outcomes. That's what we said. Now let's talk about a different experiment. Suppose we toss a coin. That's the experiment, not rolling the die. And then that set of outcomes, the experimental outcomes, are different. We could say they're heads and tails. Now remember that here we could have said that the outcomes were just even and odd. So there are different ways to describe the different outcomes, but this is one way. We can do it that way. And here we can do it this way. Okay, let's talk about some others that are not quite as sort of simple experiments. So inspect a part. What are they talking about? I guess, in a machine production environment, and check whether it's defective or non-defective. So those are the two outcomes. You check a part, and then you check whether it's defective or it's not defective. So we could say the experiment consists of these two different outcomes. And the next one is conduct a sales call. A sales call. So, and then the result could be that either the customer makes it, or the person who receives the call makes a purchase or does not make a purchase. So those are the two outcomes, or those are the two outcomes. Okay, and then here's one more. Play a football game, and we could say, and we could talk about the scores as being the outcomes, but here they're describing the outcomes as either win, lost, or tie. Okay, so that's the set of outcomes. So we're talking about experiments and their outcomes here. Okay, so you could come up with other experiments, and what would their outcomes be? For example, you could say, let's toss not one coin, but two coins. And we could say the outcomes are, there's two ways that come to mind for describing the outcomes of tossing two coins. One way you might say, this is not the way I want to go, but one way is you could say you could get 0 heads, 1 head, or 2 heads when you toss two coins, right? That's possible. Those are the possibilities. That's one way to describe the possibilities of tossing two coins, but that's not the way I wanted to do it. So I could also say that you could get heads on the first and heads on the second, or you could get heads on the first and tails on the second, or you could get you could get tails on the first and heads on the second. So I'm saying that these two are not the same, because this is heads on the first, tails on the second. This is tails on the first, heads on the second. And then the last outcome in this way would be tails and tails. So we could describe the set of outcomes this way, or we could describe it this way. So depending on what seems more useful, we'll choose one way or the other. So let's just read the rest of this screen. So they say random experiment and its sample space. So a random experiment is a process that generates a well-defined experimental outcomes, or well-defined experimental outcomes. So these are the so-called random experiments. So tossing a coin, and we get sort of well-defined experimental outcomes. Well-defined means we can say what the outcomes are. So here we can say what the outcomes are, heads and tails. And here, inspecting a part, we can say clearly what we could consider the outcomes. For example, defective and non-defective. And here, conducting a sales call, we could say the outcomes are results in either a purchase or no purchase. Or rolling a die, we could say the outcomes are this. Or playing a football game, we could say the outcomes are this. We said there are other ways we could describe the outcomes. For example, the scores. Just like here, when we toss 2 coins, we could describe the outcomes like this. Not this one. Or this way. But in any case, it's what we mean by a random experiment, so these are all random experiments, is a process that generates a well-defined experimental outcomes. So then these outcomes, like here, have a name. So we want to have a nice word to describe the set of outcomes. So I don't know exactly why we use this one, but it's called the sample space. Okay, so the set of outcomes is called the sample space. So everyone should say that word, that phrase right now to yourself. In fact, you should say it 3 times so that you sort of get used to the sound of it. So you should repeat it 3 times. I'll stop right now, and you should just say it out loud to yourself 3 times. Once, twice, 3 times. Okay, say it. So what is that? What is the meaning of that? It's the set of the outcomes. So here, it's this. For this experiment of rolling a die, what is the set of outcomes? It's here. So this is the sample space for the experiment of rolling a die. You can throw in that word for the experiment of rolling a die. You could just say, what are the set of outcomes for rolling a die? These are the set of outcomes. So these are called the sample space. Then we could say, what are the set of outcomes for tossing a coin? We could say, these are the set of outcomes. So this is the sample space. And so on. This would be the sample space. And so on. And here, this would be the sample space for the experiment of tossing 2 coins. Of course, we said we could also use this as the sample space. Anyway, that's the word sample space. So what is the sample space? The sample space for an experiment is the set of all the experimental outcomes. So it's the entire set. And then each element, so here's an element. So each element is called, what's it called? A sample point. So maybe we should say that 3 times. So say it 3 times out loud. Okay, so this is a sample point. This is a sample point. This is a sample point. Notice that a sample point in this case consists of 2 things, but it's only one sample point. So so the sample space is a set. So each of the elements in the set is separated by a comma. So you can see here there's 1 comma, 2 commas, 3 commas. So that means there are 4 elements in the set, or 4 what we call sample points. So what are the sample points? It's not H. The things that are separated here are HH, HT, TH, and TT. So the sample point is HH. The sample point is HT. A sample point is TH. A sample point is TT. Here, the sample, we would put the comma here and here. So the sample point would be 0. Another sample point would be 1. Another sample point would be 2. And here, a sample point would be win. A sample point would be lost. And a sample point would be tie. So each element that is separated by a comma in the sample space is called a sample point. Okay?